We are going to learn how to use OpenCV, which is a computer vision Python library that we can use to make some cool projects. We are going to integrate it with Arduino to create this simple project. For example, I can control the brightness of this light using my fingers. I have calculated the distance between the thumb and the index. Then we can use it to control the brightness using PWM. For now it is 100%. We can adjust it to be 50% brightness. And this is just one example. We can use the same library to create some robot arms. We can control a robot arm using our hand. So if you haven't subscribed yet, make sure to hit the subscribe button. That helps me a lot. At this point, we are not going to use our Arduino board. We're going to learn the basics of OpenCV. Then we'll create these cool projects. First of all, you have to install Python as well as the IDE that we use to write our Python code, which is PyCharm. I've already done that in our last episode, so make sure to check it out. Then you can follow along. Let's start off by creating a new project using a new project, and we can give it a name like OpenCV. Under here we have the Python version, which is 3.11. If you are using another one, don't worry, there is no big differences. Then we can create the project using this button. By default, we will have the sample code. I'm gonna get rid of it using Ctrl-A and return. This is a main.py file that we can run to test our code using this button, run. To make sure that everything is working, let's try to print something using the print method. Hello OpenCV. Then we can run it again. And yep, it is working just fine. Now we can start using OpenCV. Before you can do that, you have to install this package by going to File, Settings, and under the Python project name, which is OpenCV, we have to select Python interpreter. And here we have all of the packages in our project. Let's add a new one and search for OpenCV-Python. Make sure to select the right one on top and hit install package. Here we have installed successfully. We can close this window. To use the library, we have to import it using import, and the name is CV2. So OpenCV is an open source computer vision library. Today we will learn how to use it to read images and how to write it, as well as displaying it using a window. For example, I want to read this image, which is our channel's logo. The method that we use for that is cv2.imRead, which takes in a string, and it is the path of the image. So to get it, we can right click and go to the properties. So here's the path, but it's a little bit long. Luckily, we have another method. We can take this image and put it under our project using right click, copy. To get the project files, we can right click on our main file and select Open in Explorer. I'm gonna right click and paste it. I'm gonna give it another name like my logo. And you don't have to take all of this path. We can actually write the name, which is called the relative path. Now to display the image using our code, we have to put it inside another object like logo equals what this function returns. And the method that we use to display it is called cv2.imShow that takes in two parameters. The first one is the name of the window like my logo, and the other parameter is the actual logo object. If you run this file, you will not be able to see the image because it disappears immediately. We need to stop our code right here so that we can see the image. And the way we do that is by using cv2.waitKey. This will wait until we press a key, and that's gonna block our code so that we can see the logo image. There you go, we have our logo and the name my logo. And whenever you press a key, like the space key, we can exit out of this, and it is recommended to make sure that all of the windows are closed using cv2.destroy all windows. Now that we know how to read and show an image, I'm going to show you how to write it or save it in another format. For now we have a PNG image. To save a new one, we can use cv2.imWrite. We have to pass in two parameters. The first one is the name of the image, like my logo, and we can specify the new format using .jpeg. And the second parameter is the actual frame that we have called logo, and it is this object. Let's give it a try and check if it's working. Now you see that we have this new image in another format, JPEG. I'm going to show you how to read images from your main camera. Let's get rid of these lines of code. First of all, we have to create an object that is called video capture and call it cap as an example equals cv2 dot, and we have this class video capture, and it takes in an index that could be 0 or 1. So if you have two cameras, you have to select one of them using the index 0 or 1. For me, I have one camera, so I will write 0. Next, we can set some properties like the width and the height of the window using cap, and the method that we use is called set that takes in the property ID, or we can use a name, and it is called cap underscore property or prop, then underscore frame width to set the width like 600. Next, I'm gonna set the height using cap dot set, and we use cv2 dot cap underscore property. We want to select the frame height and use a value like 500. For now, we haven't read an image. We have just created or initialized this video capture. To read the image from the main camera, we can use cap dot and the method read, which return the image as well as a boolean that we can use to check whether we have read the image successfully. We can put these two values inside two variables. The first one is the boolean that I'm gonna call success. Then we add comma and the second parameter name, which is the frame or the actual image that we're gonna read, equals what this method returns. Then I will check if we have read the image successfully using an if statement. If success equals true, or we can simply use success, then colon. In such case, we are going to display this frame using our method cv2.imShow. The first parameter is the name, and the frame object, which is called frame. The same thing, we need to wait so that we can see the window using wait keys or cv2 dot wait key, which waits indefinitely until we press a key, and use cv2 dot destroy all windows. Let's give it a try using run. And here's the image that we have read using cap.read, but we want to continuously take these images from our main camera, and the way we do that is by adding a while loop. I'm gonna put all of these lines of code inside a while. So let's cut it using Ctrl X and write while true. In such case, we are going to use cap.read to read the frame. If it's done successfully, we can show it using imShow. The only problem with this is that the method wait key will wait indefinitely until we press a certain key, and we will not be able to see the images continuously. But if you pass in an integer like 1, this is called the delay. It is 1 second. This will only wait for 1 sec, then it will move on to the next line of code and enter this while loop again so that we can read the next frame. Let's stop this code using this button and run it again. You see that the window closes automatically, and that's because we have this line of code to destroy all windows. Actually, we have to put it outside. I'm gonna cut it. And there you go, we have the video because we are taking the frames over and over again. By the way, we can't close the window even if I press a key, because we haven't told Python to close the window whenever we press a certain key. To do that, I'm gonna stop the program from here. Basically, our method wait key returns an integer. If there is no key is pressed, it's gonna return -1. Otherwise, it's gonna be another number. For example, if you press the A key, it's gonna be 97. So I will check if cv2.waitKey is not -1. That means we have pressed a key. In such case, we are going to exit using break. To check a specific key like A, we can use 97, or you could use a built-in method that is called ord. This takes in the character like A, and it returns the value. In this case, it is 97. I will use the letter Q to quit. Of course, we need to check if it's the code of the Q key. In such case, we're going to exit using a break. If you haven't subscribed yet, make sure to hit the subscribe button. That helps me a lot. Now, if I press the Q key, we can exit out of this program and destroy all of the windows. We're going to start using MediaPipe, which is a popular library that is developed by Google that we can use for different tasks, like the hand tracking. We can detect all of the landmarks, so these points are called landmarks, that we can use to create some cool projects. Here we can detect the raised fingers. We have 5, 4, 3, and 1, and this is just one example. Whenever I put my hand, we are going to detect the landmarks, which are the key points of the hands. And to do that, we have to install the MediaPipe library by going to File, Settings, and under the Python interpreter, you have to add this package. It is called MediaPipe, and it is this one, which is a popular Python package or library. It provides you with machine learning solutions, including hand tracking, pose detection. As I said, we're going to focus on the hand tracking. Once you install the package using install package, we can close this window and import it using import, then the name MediaPipe, and we can make it shorter using as MP. We've already created the video capture object, and you can change the width and the height as you like. First of all, we have to add something that is called the solution, and let's give it a name, MP underscore hands for the hand tracking equals. Then we're going to use MP dot solutions because we have different machine learning solutions like the hand tracking, pose detection. I'm going to use dot hands. So the first variable is actually a module that contains all of the functionalities that we're going to use. But to create the actual object that we're going to work with, we have to add it right here. I'm going to call it hand equals MP underscore hands. Then we have the hand class, or it's called hands. Make sure to add the parentheses because it's a class, and we have created an instance out of it. Next, we can move on to our while loop, which is called over and over again. Each time we are reading the frame, and if it's done successfully, we can process it to detect the hands inside it. We can use our hand object dot process, which takes in our frame as an input, and it returns some results. I'm going to put it inside another variable called results or result. The only problem with this is that our frame is created using the OpenCV library, and the format is a little bit different. It is called BGR, not RGB. Basically, each pixel of an image contains 3 colors, which are the blue, green, and red. But our MediaPipe library has a different order. It is RGB, not BGR. To fix that issue, we can create another object and call it RGB frame. We have this method using cv2.cvt for convert color. It takes in 2 parameters. The first one is the current frame in BGR format, and we want to convert it to RGB using cv2.color underscore BGR to RGB, and that's what we want. Now our hand object can process the RGB frame. After that, we need to check if we have a hand or multiple hands that are detected inside the frame using an if statement, if result dot multi underscore hand landmarks. In such case, we can look through all of the hands inside the frame using a for loop. So for hand landmarks, in the result, multi-hand landmarks. Let's try to print it using print and the name hand landmarks. Then we can run it. And there you go, we have our window. And once I put my hand, you see that we have some values. I'm going to hit the Q key to check the results. You see that we have landmarks, and each landmark has a position, which is the X, Y, Z coordinates. We can use these values to create all kinds of projects, like calculating the distance between the thumb and the index. If you don't know what is a landmark, it is the key point of the hand, like the wrist, which is number 0, and it is the first landmark. Then we have 1, 2, 3, 4. You see that number 8 is the index fingertip. I want to show these points and the connections between these landmarks. And to do that, we have something that is called drawing utilities or utils. Let's go on top. I'm going to call it MP drawing equals. We can use MP dot solutions, then dot drawing utils. The same thing, it's a module that contains some functionalities to draw the connections and all of the landmarks. We're going to use MP drawing dot draw the landmarks. This takes in 3 parameters. First, we have the image that is called RGB frame. Then we have the hand landmarks that we need to draw it. And finally, what we want to draw by using MP hands. And you have different options like the hand connections. You see that we are displaying the frame and not the RGB frame. Here you have different options. You could convert this back to the BGR format, and display it. Or we can draw the connections using the first frame, that is called frame, and then display it. Let's give it a try. And there you go. We have all of the landmarks. The bottom one, which is number 0, is the west. Now I think you are ready to create these kind of projects. We can control the brightness of the LED using the distance between the thumb and the index. We are going to use MediaPipe with the PyFirmata library to control the brightness of this LED using my hand. For now it is 80%. We can set it to 50% or 0. And this is just one example. You could use the same process to control a robot arm and servo motor angle. To create this project, you're going to need an Arduino board like the Arduino Nano and an LED with a 220 ohm resistor. I've already connected the positive lead to the digital pin D3 to control it. And on the other side, I have added the ohm resistor. And now we want to control our Arduino board using Python. And to do that, we have to install or upload a code. It is called the standard Firmata code. You simply have to open up the Arduino IDE and get the Firmata library using Firmata. And here it is by Firmata developers. Under this library, you will find the sketch. You have to open it up by going to File, Examples. And here we have Firmata, and it is called standard Firmata. Make sure to select it. Now to upload it, we have to select the board. For me, it is an Arduino Nano that is connected to the COM3. Then we can hit upload. Once you do that, we can close the Arduino IDE and open up PyCharm. To save a little bit of time, I'm going to use our last sketch on how to use the MediaPipe library. Here we are just reading the frame and getting the hand landmarks using the MediaPipe library. So we'll continue by adding the PyFirmata library and control our Arduino board. We have to go to File, then Settings, and under the project name and the Python interpreter, we have all of the packages. Let's add a new one, and it is called PyFirmata 2. Make sure to select the same name and hit Install Package. And there you go, it is installed successfully. We can close this window and import our package on top using Import, then the name PyFirmata 2. Next, we have to create our board object so that we can control the Arduino Nano. I'm going to give it a name like board equals PyFirmata 2 dot, and we have Arduino. This takes in the port of the USB cable. In my case, it is COM3. Also, we have to add the pin definition to control this LED. I'm going to call it LED pin and use board, which is our microcontroller, dot get pin. This takes in a pin definition. It's like the pin mode in the Arduino IDE. As I said, I have used the digital pin number 3. So we have to add D for digital, then colon, and the number of the pin, which is 3. And finally, we have to set the pin mode, like I for input, O for output, and we have P, which stands for PWM, so that we can control its brightness. To check that we are able to communicate with the Arduino board using Python, I'm going to go under this while true, that is called over and over again, and set the brightness using the name of the object LED pin dot, and the method that we use to control its brightness is called write. This takes in a float between 0 and 1, so 1 means full brightness. Let's try to set it to 50% using 0.5 and run this main file using run. And there you go, the LED is turned on and we have 50% brightness. Also, we have the frames that are created using the video capture object, and we have used the MediaPipe library to get these landmarks, which are these red points. We're going to calculate the distance between these two. Then we'll use its distance to calculate the brightness and adjust it. Let's continue. So each time we are taking the frame from the video capture using cap.read. If it's done successfully, we can process it using hand.process. Then we can check if we have detected the hands or the hand landmarks using result.multi-hand landmarks. In such case, we can loop through all of the hands. We could also adjust this code. We only need to take one hand. And to do that, we can pass it in as a parameter. This is actually a class. If you hold down the control key, you will see all of the parameters that you can adjust, like the maximum number of hands. By default, it is set to 2. We can change it using the name max number of hands equals and use 1. So we don't need to loop through all of them. I will simply check if we have a hand landmark. In such case, we will take the first one and put it inside another variable like hand landmarks equals result dot multi-hand landmarks at the index 0 because we have one hand. Now that we have all of the hand landmarks, we need to calculate the distance between these two using the index 4 for the thumb tip and number 8 for the index tip. So I'm going to create two variables. The first one I'm going to call it thumb tip equals hand landmarks dot landmark at the index 4, and the second one is going to be the index tip equals hand landmarks dot landmark at the index 8. For now, let's try to print these two objects using print the thumb tip and print the index tip. Also, I want to add a little bit of delay by using the time library. I have to import it. It is called time and use time dot sleep 1 second or 2 seconds. And let's run the main file again. And if I put my hand, you see that we have some measurements. The first one is the thumb tip. So we have few parameters, which are the XYZ coordinates. The same thing for the index. We can get the position. And here we're going to use a little bit of math. So to get the distance between 2 points, we have to use this formula. And these 2 points are the landmarks that we have taken. As you can see, we're going to use the square root. So we have to import a library that has this functionality. Let's go on top and import it. It is called math. You don't have to worry about installing this package. It is built in. And let's go down and write the same formula. I will create a variable and call it distance equals math dot, and we have the square root. Then I'm going to use the difference between the x values of the thumb and the index tip. And here we have the power of 2. Then we're going to add the difference of the y values. So let's copy it again and paste it. Make sure to use thumb tip.y and the index tip.y. And let's try to print it to check out the result. And there you go. Now we can get the distance. As you can see, it is about 0.6. Let's try to adjust it. You could also add 2 lines using the picture or the frame. For now, it is 0. We can use this value to adjust the brightness of the LED. So we'll use LED pen dot right and pass in the distance. You could also rename it to brightness if you want. I think that's all what we have to add. And there you go. We can adjust the brightness of the LED. Now it is about 0. So I think that's pretty much it, guys, for this video. If you have any question or comment about this project, make sure to write it under the comment section down below, and I will see you in the next one.